Yeah, it's the same error, similar to what Sid said for number 1. So we're going over the common errors. This is in your green Be Prepared packet. So the first error was assuming that if the second derivative is 0, you automatically have a point of inflection. That is an error. That is wrong thinking, okay, because you have to justify or test it. Same thing with the second one. Just because you have a critical number, does it necessarily mean it's a max or a min? Absolutely not. What graph can you think of very quickly? X cubed graph, right? You're going to have a critical number at 0, but is it a relative max or min? No. Okay. And then they give you in this like a problem where students, missed it on an AP exam. So they gave you 2 of them actually. Okay, the third error is what? It's the biggest one I've seen this year actually.
It's like, they basically just made up their own formula for average rate of change.
They made up their own formula for average rate of change. You got it. They used logic with what they knew about an average, but in calculus, we haven't done any averages that haven't had a difference in them. So we always use slope if we're using average rate of change. Guess what the other error is? Because this is the formula.
Oh, wait. I was going to say average value of a function.
Okay, so they may an average value of a function is very related. You can actually use one for the other depending on if you can integrate. But what did some people do this year that actually gives you units that are like meters per second squared as opposed to units that are meters per second? Someone thinks find this average velocity. What do you think people subtract?
Velocities rather than position.
Yeah. So if you subtract velocities, you would be finding the average acceleration. So think about it in terms of units. If you're taking position minus position, you'll get position units over time. If you were subtracting velocities, you would have like feet per second, which is actually acceleration units. Okay? All right, what was the error in number 4? This was a big one.
The volume by washer formula, they squared the value of r minus little r, big R minus little r, and instead it's big R squared minus little r squared.
Exactly. Yeah, this is wrong. The correct form would be pi big R squared minus little r squared. Okay, and I didn't see that as a huge error this year with you guys, which was good, okay, because it's a real common error. All right, what was the error for number 5?
Separating differential equations can be solved without separating the variables.
Yeah, there are tons of differential equations. The only one that we learned the method to use in AB calculus is by separation of variables, which means get all your x's with your dx and all your y's with your dy. On an AP free response question, if you don't separate variables, if it's 6 points, you miss all 6 because you can't do anything if you don't do that first, okay? So they give you like a sample problem. And if you want extra problems and you want to do these, all you have to do is Google AB Calculus 1997 number 6. And that's going to come up and you'll probably find the answer somewhere quickly, okay? All right, what was the error for 6?
Basically, it was like forgetting about like the inside chain. So, like they wouldn't take the derivative of the y inside the function.
Exactly. So when it's a composite function like this one, let's look at this one actually. This is the same thing as cosine of x cubed squared. So you'd be taking the derivative of u squared, which is 2u times u prime. So you'd have 2 cosine of x cubed times the derivative of cosine of x cubed. And lots of times we forget that. Okay, and you guys had 7 as well. What didn't they want us to ever use?
You can't just say if I'm referring to a port that the problem is asking for. You have to specifically refer to as like the derivative of f of x.
Exactly. Yeah, exactly. If you say it changes sign, they don't know what you're talking about. Okay, so just be careful on using that. Then I gave you guys 8, 9, 10, 11. So what was 8?
So for 8, this is just saying what you are allowed to use your calculator for is those 4 things listed on the 3 responses, and then it's reminding you that whenever you're writing it down, you have to set it up in like the correct math notation, not calculator notation.
Okay, yeah, good. So these are things that you can do on your calculator when it's free response. Multiple choice, they don't know what you're doing. So if it's a calculator part, you can do anything you want. But this one, you can graph, you can find intersections, you can find zeros, you're allowed to find a window, you can integrate a definite integral, you can find the derivative at a specific value. But you can't do things like, I found the max on the calculator, because you're not using calculus, okay? All right, and then universal log anti-differentiation, making sure you remember those absolute values. And then what was 10 and 11?
And those don't mess up like the algebra. Don't make the simple mistake of messing up the algebra.
Yeah.
Do all the trading calc stuff.
Yeah, so bad algebra is a huge mistake, and it's one of the biggest things that I saw this year. That's where we tend to make our mistakes, is on the algebra. Think about all those derivative things we were doing. We'd take the derivative correctly, and the simplifying part kind of was the part we messed up on. And then forgetting,
So 11, you just forgetting the plus C for just C, E to the KT.
yes,
Integrating.
good. Yeah, so 2 different times, the plus C when you're integrating, or the plus C anytime you integrate, if it's not a definite integral. And then in this problem, making sure you have the plus C and solving. They give you a whole differential equation problem with the solution. So that's something you might want to practice. And then number 12, omission of units. So that's a common error that they see. This is not the top 10, it's the top 13. And then number 13 is rounding too early or not rounding to 3 decimal places. You can see on one of those free response that we did on the test, chapter 7 test, you could miss 3 points plus you just for rounding, which I think is really not a good way to grade calculus, because if you did all the calculus right, I think they've kind of fixed that by now. I don't think you would miss 3 points for round. 3 points for rounding is pretty harsh on an AP question if you did everything else right. So I think they've kind of worked on making sure that that isn't what they're looking for, and giving points for really the calculus stuff. But you will miss points for rounding, so be careful. Okay? Any questions on those? Now, all of these problems, if you want to work out, like if any of them you were like, oh, maybe I should practice that, I do have the solution, so that's something tomorrow that if you did any of them, you ask me and I can show you those solutions. You'll see that tonight's homework, you don't really have an assignment sheet for today or tomorrow. Tonight's homework, I am going to give you that test N, because most of you said that you would use another AP practice test, and I'll post the solutions. I haven't done that yet, but I will. Do what you need to do, okay? So what does that mean? Well, for some people it might be they need to do some more multiple choice calculator stuff. For some people it might be they need to do more free response stuff. You might look through this test and see the 6 free response, and you might look at the 2 that you need more practice on. So it's all individual. It's basically a study. And that just depends on what you need to do, okay? And you have lots that you could do. So the practice stuff that I'm giving you, this is a whole test. This is test, I call it N. So it has a full test. It will look like what you will see next Tuesday, okay? Do you have to do it all? No. If you want to do it all, can you? Yeah, it's just practice for you. If you look in there and you go, yeah, I don't like these free response questions because I think that I know how to do these, then go onto the College Board website when you did that scavenger hunt, where there is a bank of all kinds of questions, and you could just pick and choose what you need to do, and the solutions are there as well. Okay? All right, so let's go over the in-class multiple choice. Do you remember that thing that are stapled together a whole bunch of times? There's a whole bunch of them. In your folder. And while you're finding that to see what questions you have for me, I'm giving you back the volume test with solutions attached. Now that is a homework assignment for tonight. And that homework assignment is to go through and correct that volume test, because you want to know what you missed and why. And then tomorrow I can go through any questions that you have. They were curved out of 50. But I will tell you that there are several people in here that need to get that volume area worked out, okay? So that is the one homework assignment for sure that I want you to do for tomorrow, so that I can go over any questions you have, okay? All right, so let's look at that multiple choice. These were the time, and I think when you got the solutions, it said 1998. This was one they gave a long time ago. You can see that some of the questions don't change. Some of them sure do. What numbers, as you looked through it and tried to correct it, did you have questions on? We only did the non-calculator part, so it was 1 to 28. If you're not going to ask, I'll pick out ones that relate to some of the things people asked about. Number 4 would be one of those questions. And again, what you're looking for is the stapled. You have like 4 or 5. If you didn't come in and take the rest of it, I probably still have it, so you might not be able to find it because you never finished it. Okay, so number 4 said if a function's continuous and differentiable. Ooh, that sounds like what theorem? Function has to be continuous on the closed, differentiable on the open. MVT or possibly Rolle's, but in order for it to be Rolle's theorem, what other thing do we need to know? F of A has to equal F of B, so that's why B could be false, because they didn't put the other stipulation for Rolle's theorem. This is how they could ask a theorem question, which is tricky because you have to know that theorem inside and out. Okay? What other numbers? That one was one that I just looked at and I was like, oh, someone had asked about this. Any others, or were you able to clear them up with the solutions? Let's look at 15. 15 is asking you to use what theorem? Second fundamental theorem, yeah. Second fundamental theorem, the derivative of an integral. The derivative of an integral, if the bottom's a number and the top's just a plain old x, you just throw in the x. Now let me change that one a little bit. What if it were -1 to x squared and they asked you to take the derivative? Plug in the x squared, so I'd get the square root of x to the 6 plus 1. Then what's the part that people miss? Yep, times by 2x. Okay, so that's second fundamental theorem. So that's a real probable type question. Any numbers that you needed? Trying to look through to see if there were any others that I really thought were tricky. Looking at 21, they just wanted you to know, hey, that's that differential equation we're allowed to memorize. The solutions were going to be y equals c e to the kt. So I just picked out which one was in that form. Any on that set? What about 23? Because some people had asked about, like, if you're given a derivative graph or a function graph, this one gives you f. Want you to know which one matches with the derivative. So let's look at this one. This one's a good one. If this is f, then when I do the derivative, where do I have to have a 0? Wherever that relative max is. So there's one there. This one has 2. There's not 1 here, so I can eliminate it. There's not 1 here, so I can eliminate it. These both have it, so it's between A, C, and E. So then, since the function increases, the derivative has to be positive, so it has to live above the x-axis until it gets that 0. So I can eliminate that one, right? And then it decreases, so it has to live below. Now it's not going to be e because this isn't quadratic. So I know that can't be linear, so it had to be a. The whole idea that the derivative of the cosine is the negative sign, that kind of thing. Okay, any others on there? 26 was IVT. Function is continuous on the closed interval. What value could k be? You've seen this one before. If 0, 1, and 2, 2, and it's continuous, what does k have, like in order for this to work, why does k have to be 0? If there's two solutions for where y is a half. What if the answer k were just a half? Would there have to be two places it crosses y as a half? No. So it has to go below it so it crosses twice. All right. Anything on the 1 to 28? Okay. All right, let's look at the one that I gave you solutions for on Tuesday. Which ones do we need to take a look at? So it was the sheet that looked like that. Any that you couldn't get or that you have questions on? Yeah. 82. Yep, so let's go to page 76. Number 82. This is a good one because this is going to review those theorems again. So people that asked about IVT roles, and this one's a good one for you. So read page 76. Hopefully you tried it already. If the function's continuous on the closed interval, which must be true? What part isn't it saying so that I know I can't apply mean value or roles? Doesn't say it's differentiable, okay? So I don't know that there's a place where the derivative is 0 because it doesn't have the stipulations for Rolle's theorem. I can't use mean value theorem. See how they're testing that? So I have to figure out of the other 3. There's a number c in the interval where the function equals 0. We don't know that. Okay. There's a number c where f of a is less than f of c is less than f of b. We don't know that either. We just know that there's a number in that closed interval where f of c is going to be greater than or equal to f of x. This is what theorem? What theorem? Intermediate value theorem, right? So it just means you could have a function that's continuous that looks like this. You could have a function that's continuous that looks like this from a to b. We don't know that it can be equal to 0. We don't know that the f of c is going to be less than the y values. We just know that there has to be some number c where f of c is going to be greater than or equal to that function's value. Okay, so that one's tough because you have to eliminate and you have to know the theorems pretty well. Okay, what else? Yeah.
28.
Number 28. So let's go back to page 37. No, which one? Test B or test C?
Test B.
Test B. Okay, page 37, number 28. All right, this is a good one. I wanted you to do this one because a couple of people asked for exponential growth problems. Okay, so that's exactly what this one is. I think you asked in here, someone asked 9th period. So at any time t is greater than or equal to 0, the rate of growth of bacteria population is given by this differential equation that we're supposed to know real well. It gives us this solution. Y is the number of bacteria, K is a constant. Initial population is 1,500, so at time 0, Y is 1,500. I can find the C value. The population is quadrupled during the first 2 days. So from 1,500, it goes 4 times that to 6,000 in 2 days. So I can solve ln both sides and find the K value. K actually turns out nice. It's ln of 2. Okay, even if you left it, this was non-calculator, so you wanted to try to simplify it. Then it wants to say by what, they want you to answer by what factor will the population have increased during the first 3 days. So I want to find out what is the population after 3 days. I want to put that K value in. I find out it's 1,500 e to the ln of 8. E to the ln of 8 is just the number 8, so it's actually 8 times the original population. Now, not only did that one want you to know the differential equation and the solution you get, but that was a lot of pre-calc, okay, in order of solving a lot of properties of logs and exponential things. What else? Any other numbers? Because those specifically I picked because they were ones that you had mentioned, topics that we needed more practice on, and they weren't all easy. Anything else? Okay, if you didn't do it and you do it, I'll ask the same thing tomorrow, okay? Let's look at the packet of problems that I gave you that looked like this. So I gave you this Tuesday, and this was for you to practice last night. What I tried to put in here were things like someone asked about L'Hopital's rule. So number 1 hit that. In order to use L'Hopital's rule, you have to end up with 0 over 0 or infinity over infinity when you do direct substitution. L'Hopital's rule lets us take the derivative of the top, the numerator, over the derivative of the denominator. Then when I plug in pi, I can find that answer. I really could not have done that specific problem any other way. Could have made sine 2x 2 sine x cosine x, maybe. That would have worked. And then did direct substitute, but the bottom would still be 0. So yeah, I think that one they were just getting at, you have to know L'Hopital's rule. Anyone have a question on 3 or 4? 4 I threw in because it was a related race. Okay. Oh, and you don't know the answers, do you? BCA. So in case you didn't do it yet, if you had an AP test or whatever, BCA for the first page. Okay, let me give you the second page. AB. So 5 is A, 6 is B. So I'll give you all the answers and then we can go back. 7 is D, 8D, 9B, 11A, 12A, and then the last page, D, C, D, B. D, C, D, B. And I will tell you, I thought 16 was the toughest one. It took me a couple minutes. Did you try 16 yet? That one was tough. That one you had to, they wanted you to find out how far the race car is going to travel, and they gave us the acceleration. So I knew if I integrated acceleration, I'd get velocity, but I had to tack on that 80, which was the initial condition. Then the trick on this one was, during this time period, how far does it travel? So during the time period where this is equal to 0, I had to find that moment. It was at 3.339, which I stored in A. And then I had to integrate from 0 to A, that velocity function. I thought that one was the hardest one. All right, while you look to see if you have other questions, I'm gonna give you back your in-class 2 free response tests that you took. Now, if you didn't take them, or a piece of it yet, then you won't get that back yet. But what I did is I added them together, so now you're gonna get another approximation for the AP test. And this one should be a pretty decent one. The only thing, this one will be a little bit elevated because some of the questions you had seen before, okay? So this might be a little bit higher. But now you have a score that you can add to those multiple choice scores I gave you. Okay, so you have a couple multiple choice scores, and now you have a free response score. Now, does this mean you're gonna get this score on the AP test? No, you're gonna come in after the AP test and you're gonna tell me the next day, oh my gosh, it was hard. We didn't see problems exactly like those. You will not. It is more concept questions. On the free response, what I'm talking about, the multiple choice, you may come in and say, yeah, it wasn't too bad, there were a couple. But the free response, every year, so just prepare yourself. When you go in and look at them, you're gonna go, oh my gosh, we didn't do ones like this. Okay? Because we won't. I can't dream up of what the questions they'll have on there. Okay? All right, so that gives you a score. Now what I did is I curved majorly. I gave you a 20-point score just for taking it those 2 days. So those scores are, you have a nice score for that. But now hopefully you can add some of the scores I've given you together to get, an approximation of where you're landing. Really, really, really think about what you need to practice the most. So again, if you go back through those checklists, if there's not something that we talked about or you haven't practiced, because I tried to address each of those questions in some type of thing that we did, let me know tomorrow, okay? Because we can look and do something on any of those topics tomorrow. So homework tonight is correct your area volume test number 1.
Wait, Sunday night.
Okay?
Always Monday night.
What's Monday night?
Sleep.
Oh, sleep is Monday night, yeah. That's your homework Monday night. Yeah, I thought he was gonna say like cram for the test. Yeah, you can't procrastinate. One more.
So if we weren't here yesterday, should we be taking?
Yeah, if you weren't here yesterday, if you can let me know when let's make arrangements for how to make